In previous videos, we looked at the hyperbolic sign, examples of the hyperbolic sign and also the hyperbolic cosine. Now what we want to do is look at the hyperbolic tangent. Now we know that the hyperbolic sine of x is equal to e to the x minus e to the negative x over 2. And the hyperbolic cosine of x is equal to e to the x plus e to the negative x over 2. Now, we know that there is a certain identity in circular functions, which is the usual trigonometry that we've been used to. Alright? The trigonometric ratios. There's an identity that says sine x divided by cos x is equal to tan x. Now, let us model that using the hyperbolic sine and cosine, and see if we can come up with the hyperbolic tangent that way and then test it with an example. Suppose you consider sin x divided by cos x equal, now the tan h. I see where in a certain book, engineering mathematics book, they say it should be pronounced T-H-A-N with it th, just like how you say than, T-H, alright? Now, sometimes I refer to it as tanch, but anyway, the tanch or than of x. Now, if that is so, then what you'll have is the e to the x minus e to the negative x divided by 2 all over the cos, or this was from a previous work that we did, divided by cos x, which is e to the x plus e to the negative x divided by 2. Now, once you remember your fraction, you would know that this is e to the x minus e to the negative x divided by 2 multiplied by the reciprocal of the denominator fraction, which is 2 divided by e to the x plus e to the negative x. Alright? So, the tan of x equal e to the x minus e to the negative x divided by e to the x plus e to the negative x. Alright? Now, suppose we consider an example. The tan of let's say 1.65. Alright? This would be the same thing as e to the 1.65 minus e to the negative 1.65 all over e to the 1.65 plus e to the negative 1.65. Now, of course, it's probably a bit easier on the brain if you write this as 1 divided by e to a positive power. So you have e to the 1.65 minus 1 over e to the 1.65, alright? Divided by e to the 1.65 plus 1 divided by e to the 1.65. All right. Now, therefore, the tanh of 1.65 is equal to, let's see how we can work this thing out. Let's use our calculator. So here now, E raised to the power of 1.65 is equal to, all right, let's say 5.207. So e to the 1.65 is 5.207 to 3 decimal places. So let's work with that. 5.207 minus 1 over 5.207 all over 5.207 plus 1 over 5.207. All right, equal 5.207 minus, let's take this as a single number. So here now, 1 divided by 5.207 is 1. Let's put 1 over that, equal 0.192. So 0.192 over 5.207 plus 0.192. So what this is saying then is the tanh of 1.65 is equal to, now let's work this out further with our calculator. 5.207 minus 0.192 equal, you have 5.015, and then that must be put over 5.207. Now in this case you have plus 0.192 equal 5.399. So it is 5.015 over 5.399. What happens when you do that? 5.015 divided by 5.399 equal 0.929 to 3 decimal places, 0.929. So we have 0.929. Now, this is saying that the tanh of 1.65 is equal to 0.929. Now we're going to look at doing it directly with the calculator. So let's see how that goes. We want to find the hyperbolic tangent of 1.65. What will happen here? Okay, 0.929. So there we go. So that shows evidence that we are correct here. So the hyperbolic tangent of x is e to the x minus e to the negative x divided by e to the x plus e to the negative x. It is the same as sine over cosh.